opportunity to have a Q&A session with Dr. Baswati, and I hope I'm pronouncing that right. She's a holistic physician trained in family medicine and preventive medicine. She's also a scientist trained in pharmacology, neuroscience, and ancient Ayurvedic chemistry. She will be talking to us about body hacking and how you can optimize your body with Indian medicine, which I know nothing about, so I think it's going to be quite eye-opening for a lot of us. And before we get to meet this very impressive lady, our next speaker is Paige. Paige has been working on machine learning for 12 years, and she has worked for NASA, Chevron, and Microsoft. She's a brand new product manager at Google IA, and she's working on TensorFlow with Chris Ladner, the creator of Swift. Today, she will be introducing us to Swift for TensorFlow, and she will bring a very fresh perspective to Swift since before last year, she had never written one line of Swift code. So, really looking forward to hear what she has to share. Ready?
Awesome.
Okay, awesome. Please welcome her.
Cool. Thank you so much for having me today. I'm really excited to be here to talk to all of you and to learn a little bit more about the Swift ecosystem. As was mentioned, before last year, I'd never written a single line of Swift code. I had been completely into C++ and C and Python and R, so it's been a really refreshing change. A little bit of background, though most of this was already covered. My name is Paige Bailey. I'm dynamic web page pretty much everywhere on the internet, so feel free to reach out if you have any questions after the talk. I've been doing machine learning for a while, started out with traditional machine learning before diving into deep learning, and I'm currently working at Google AI on Chris Ladner's team to help build out Swift for TensorFlow as well as MLIR. My background is geophysics and applied math, and then I did grad stuff in carbonate geology and computer science, and I'm based in Mountain View, California. Cool. So diving in, a brief outline for today. We're going to talk about Swift for TensorFlow. Why is it useful for deep learning, and why is deep learning in general useful anyhow? And then also how you can get started. So just as a quick pulse check, how many of you have heard of Swift for TensorFlow? Okay, cool. About half of the audience. That's great. And how many of you have actually tried using it? Not as many. Okay. So hopefully, by the end of today, you'll be excited and incentivized to go and learn a little bit more about our framework. Deep learning has really touched lives in a number of ways, right? So at Google, we use deep learning for everything. So we've ingrained it into Gmail. If you notice autocomplete, sort of suggesting the next best words for you to include in your messages. If you type things into your phone and you recognize that there are words that pop up as potential next best words, being able to detect specific objects and pictures, being able to do automatic translation with a single model, no matter how many languages you're translating from one to the other. All of that is possible through TensorFlow. And TensorFlow, as I mentioned, it really touches every single bit of our lives, not just at Google, but also externally. So deep learning has also kind of taken over the academic research space, right? So here you have the number of archive papers per year, and you see that you have a massive number of machine learning papers being published every single day. So it doesn't look like this trend will not continue. If anything, we've beaten Moore's law. So this is something that'll become even more pervasive in the coming years, and it's a great thing to add to your toolbox as a developer. We've also seen incredible accuracy improvements in deep learning models. Oh, gosh, that's not good. Natasha? Cool. So for whatever reason, the slides have not been showing. Thank you for saying that, by the way. I'm just sitting up here being like, yes, deep learning. Wonderful thing. I could also do an interpretive dance. How would one even do that for deep learning? Just like, ah. Oh, wait, no, guess not. I broke the presentation. It's not working for some reason. Maybe not setting it as excellent. Awesome. Thank you so much. So, rapid fire through the initial slides. Swift for TensorFlow is a thing. I'm going to be the one talking about it. We have an outline. Lots of applications. Exceeding Moore's law. Lots of accuracy improvements. And that's where we were. So, excellent. All right. So, accuracy improvements. The really interesting thing about this slide is that these improvements, these enhancements to machine learning algorithms, these step change percentage enhancements, were created not just by trying the same things over and over. They've been tried by implementing very, very different sorts of techniques. So doing things like algorithmic fusion to bring Monte Carlo searches and neural networks together, or by adding sort of traditional programming patterns into neural networks. So really, it's not through just sort of copying and pasting code that you would find in Stack Overflow, or just copying and pasting it in really interesting ways, right? Like, so in ways that were historically unthought of. And since Google is an AI-first company, we've been using deep learning through all of our products, right? So everything from Android to Gmail to YouTube, anything that you can access probably has deep learning embedded within it. We've also seen really, really impressive performance through using specialized hardware for deep learning tasks. Here you see a couple of examples of TPUs, as well as TPU pods. And through these hardware architecture improvements, we've been able to take models that used to take days or even weeks to train, and have reduced that amount of time to something like 4 hours, sometimes even minutes, which is kind of awesome, not just from a like, hey, you know, if you make a mistake, and then you have to wait 28 days to figure out that you made a mistake. That's really sad. But it's also from the perspective of, man, you don't have to pay for compute time. Like all you have to do is spin up TPUs for the same price as you would pay for a cup of coffee, and then suddenly you have your answer. So with Swift for TensorFlow, we've observed these changes, right? So this need for step change performance improvements that can only be brought about through blending in a whole bunch of different technologies, and also the need to access accelerated hardware with the realization that Python is kind of a trash language. And this is coming, well, so for these tasks, right? So it's coming, and I am a Python person. I've been using Python for the last decade plus. I've contributed to Python as a programming language. And again, like most people that have used Python substantially for the past however many years will absolutely tell you, man, I hate Python. Like, but it doesn't really give you the kind of tooling that you need in order to do these really low-level tasks, these things where you have to be religiously dedicated to performance improvements. You need something a little bit better. And the nice thing about Swift is that it looks kind of like Python. right? It gives you all of those nice performance advantages, but with a friendly syntax that's kind of intuitive and immediately straightforward to understand. To build a deep learning model using Swift for TensorFlow, it looks just like this. And if you've ever built a machine learning, model using TensorFlow itself with Keras, it probably looks something very similar, right? So you import TensorFlow, you create a model with some layers that you want to be able to include within that model. And then we've built in differentiation, automatic differentiation, right into the programming language. So you can differentiate any function. You can automatically obtain the gradients in a really straightforward and intuitive way. So again, all of the code required to build a deep learning model contained on a single slide. That's pretty cool. To train a model, all you would have to do is define an optimizer, a context, and then just a regular for loop, right, where you cycle through and you return the entropy against your gradients. Swift is particularly wonderful for machine learning in the sense that it's cross-platform. So it can go anywhere C++ can go. And that means Linux, Mac, Windows, Android, iOS. And the syntax, I mentioned that it looks pretty similar to Python. It also looks pretty similar to Kotlin. And if you compile down a Swift for TensorFlow model, it turns into a .so file, which any developer can access through whatever UI they prefer. So that's pretty cool. Right now, whenever you deploy a machine learning model, you probably have a data scientist somewhere that's implementing it in Python. That has to be refactored into something that's more performant, like Java or C++. That gets deployed to an edge device or a server somewhere. And suddenly you're managing like half a dozen models over time, half a dozen different data pipelines. And you're giving your users drastically dissimilar experiences, whether or not they're accessing it from an Android app or an iOS app or a browser somewhere. And that's really frustrating. It also makes it near impossible to do A/B testing because you're not giving your users similar environments and you can't be empirically accurate about the testing that you do. It's also great from the sense that you have typed APIs, static detection of errors, semantic-aware autocomplete in all of your developer tooling, and customizable abstractions. And in terms of Swift, for interop, you have no wrappers. You can just import a C header or C++ header and call it. Our team has been building out C++ interop support, so if you have any interest with that, feel free to reach out. We also have full Python support. So for all of the people from the machine learning space who still enjoy using the tooling from the data science ecosystem in Python, they absolutely can. We've also, as I mentioned before, integrated differentiable programming directly into the language, which means that you have custom derivatives, user-defined types, and it's flexible wherever you need it. I was also informed before I stepped on stage that I should be keeping an eye on time. So I am holding out, putting my cell phone down so that I will be jumping off the stage before I'm dragged off. We also have language integrated autodiff. So any function that you call using Swift for TensorFlow is differentiable, and we're hoping to upstream that capability direct to the Swift programming language as well. For performance, I kind of touched on this before, but Swift is fast. So anecdotally, a couple of things. So we have seen in a collaboration that we did recently with the creator of FastAI, Jeremy Howard, that Swift was many times more performant than other kinds of data pipelines that you might have within Python. And we've also seen, so another example, AlphaGo Zero, if you've heard of that project from DeepMind. They could not implement AlphaGo Zero, which ended up beating humans at Go in Python, or using any traditional machine learning framework. they had to implement everything in C++ just for performance reasons and because they needed to be able to have tight control over I/O. They were able to re-implement parts of AlphaGo 0 using Swift and saw exact parity with C++, which is kind of cool. They were also able to do it in a substantially smaller amount of time and much fewer lines of code. So it's really been interesting to see how this has accelerated the productivity of machine learning researchers who had historically only been given C++ as an option. You also have things like thread level scalability because no GIL, which is great, and automatic graph extraction. And this all supports that concept that I was mentioning before of algorithmic fusion. So this is a picture that was taken of a recent collaboration that our team has done with Jeremy Howard of FastAI. He had created a Python library on top of PyTorch. And historically, it was really interesting in the sense that he used to be a TensorFlow person. He got really frustrated with TensorFlow because it just wasn't fast enough. Migrated to PyTorch, which had kind of a different architecture. It was a whole bunch of C++ with a thin Python wrapper. And after that, he has since migrated back to TensorFlow, not to TensorFlow proper, but just to Swift for TensorFlow because of the same reason, like performance in PyTorch wasn't good enough, and now he's back to Swift for performance reasons. And he's actually re-implemented his entire FastAI library, as well as the entire FastAI curriculum for machine learning in Swift, which is cool. And it's all free and open source and ready for you to use. I mentioned as well that we've been collaborating with DeepMind in terms of AlphaGo 0. We've also kind of helped with something called OpenSpiel, which is an open source collection of reinforcement learning algorithms that contains over 25 games, and it's ready for you to try today if you want to explore how Swift can be used for reinforcement learning. Some other really interesting use cases, right? So I mentioned that it's great as a machine learning engineer that you would be able to create a single model and then to be able to deploy it to any target hardware architecture without having to change the model fundamentally. There's also something that's becoming increasingly more important, the concept of on-device training and model personalization. So an example would be if you have a mobile device, you might have noticed that at some points in the day, your screen it adjusts for brightness. So it might realize that the room that you're in is a bit lighter or a bit darker, or that the app that you're trying to view is a little bit lighter or darker, and automatically make adjustments for you to make the screen more readable. This is all done through machine learning. And you can either take a model, train it on a server somewhere and deploy it and hope that it works the way that it's supposed to. Or you can take a base model, deploy it, and as a person makes changes to the brightness on their cell phone, your model learns from those changes that were made without having to send any data back to the server. And that's really awesome in the sense of GDPR, but also in the sense that you're able to get these sort of hyper-personalized experiences without necessarily having to send any data back to any cloud, wait for a bit, retrain. So it's happening immediately. It's happening in real time. And it really impacts the way that your users interact with your apps. Another example would be sort of this ambient home temperature devices like you have with Nest. Right? Like it might learn that whenever I walk into the house, I turn down temperature. I usually walk into the house at the same day or the same time of day. And it would automatically learn like, hey, it's about to be that time of day. Paige usually turns down the temperature a little bit. We should probably do that before she walks into the house so it's perfect for her when she arrives. Or there's another example. So hearing aid companies, they often have hearing aids that are paired by Bluetooth to mobile device. And their users would custom tweak the volume If they're in a room that's incredibly loud, or if they're speaking to somebody with a particular pitch to their voice. And eventually, the hearing aid would learn how to do that over time, again, without sending any data off of the user's device. So those sorts of experiences, really, really powerful. You can't do those with Python. Python doesn't really go on mobile or embedded devices. And I hear Swift is pretty good at mobile devices. So it seems to be a natural fit. And in terms of developer tooling, we've built out a bunch of documentation on tensorflow.org/Swift. We've included Swift sort of visualization tools as part of Google's Summer of Code. So if you've heard of SwiftPlot or SwiftML, they're both projects by our students that they completed in just the space of a few months. And we've also added support for Swift in Jupyter notebooks. So these interactive sort of playground experiences that data scientists really, really love, you can go and try out Swift in them today as long as you have a Swift kernel installed. There's also support from the community in terms of Visual Studio Code. So if you're not an Xcode person, there's a sort of maintained Swift extension that'll allow you to work. And we also are really excited about the future directions that we're headed towards. All of our design meetings are completely open. You know about our roadmap oftentimes before the rest of the TensorFlow team does. And all of our discussions are available for people to participate in on Google Groups. So if you want to get involved, you absolutely can. Automatic differentiation has been landed. Mobile and embedded device support is in flight. Default generic arguments, C++ interop, concurrency, ownership, support for specialized hardware, integration with MLIR, if you've heard of that, which is kind of the next layer on top of LLVM. All of that is planned for the next upcoming 2 or 3 quarters. If you want to get started, Swift for TensorFlow, completely 100% open source. As transparent as we can possibly make it, github.com/tensorflow/Swift. We have a whole bunch of Colab notebooks available for you to use free of charge. If you want to try out Swift on a TPU, you can. And if you want to stay informed, there you go. So swift@tensorflow.org, the mailing group. You can learn more at that address and go build. Awesome. And we have open design meetings every Friday at 9 a.m. Pacific. So hope to see you there. Thank you. Thank you so much.
Thank you, Paige. I had no idea that you are doing everything open source. That's amazing. Really good. Public service announcement. After the break, we are going to be on stage 2. So this is 1. This is like Jersey boys are coming here. We want to go across for the 2 final presentations. And don't forget, we have a coffee break until 16:45. And don't forget that at 16 sharp, we have a Q&A with Dr. Baswati. See you all later. Enjoy your time off.